All right, let's start the class now. We today we're going to study number theory. Okay, this about numbers. So we begin with factors and the divisibility of the numbers. Okay. First of all, give a number, right? And sometimes you want to figure out what this is a product, what numbers. Okay, it's a reverse procedure. Okay. For example, we know that like 12, right? 12 is going to be 3 times 4. Everybody knows that. But 4 is also is 2 by 2. Okay. So yeah, that's right. 4 is going to be 2 times 2, and then times 3. You can exchange the order. So this is called prime factorization. Okay. Now, because 2 times 2 can be also written 2 squared times 3. So we call it prime factorization. Why prime factorization? Because each factor is a prime number.
Last year, didn't we talk about this last year as well?
Hmm?
Like last year. Like,
Yes.
Yeah.
Yeah, last year the elementary class, right? Yeah. Okay, yes. Well, but we're gonna. I said begin with that, doesn't mean, right? This is called the prime factorization. You have to write as product of several terms, all the prime numbers. Come on, this guy's coming. Please turn off mic. Yes. All right, prime factorization. The next step is we're trying to learn how to fact prime numbers. Yeah, that's right.
There's no way to permanently mute to like ban use all.
Right, so the next problem, for example, like 18. Okay, first step, we know that it's 2 times 9, right? 9 is 3 squared, so it's simply write 3 squared. So 2, 3 are prime numbers. That's called the prime factorization. Okay, I'm going to ask you to do problems. 24. Okay, can you do that? Prime factorization, factors 24 as to make sure it's a product of several prime numbers. Okay, so it's going to be 3 times 8, right? That's for 7, but 8 is 2 cubed, so 3 times 2 cubed. But usually we write the smaller prime number first, 3 cubed and 2 cubed and times 3. Now my next question is, what number is called a factor of a number? Fact. Okay, a factor of a number. What's the definition?
It's like a number times some other number will equal that number.
Okay, so okay, let's take a look at 12. Okay, 12 is 2 squared 3. So factors of 12, okay, could be any number which you can use to divide. If 12 is divisible by some number, that number is called a factor. Okay, so 1 is a factor because 12 it can be divisible by 1. Yeah. And then 3, yes, 3 is a factor. Okay, because 12 divided by 3 equals 4. But 2 is also a factor, right? Then, yeah, 4 is also a factor. Then 6, and the 12. All right? So here, because the number is small, I can list all the factors. Okay? We can list all the factors. The question is, how do we count very general, right? Right? And even, we want to know how to add this, how to add them together, the sum of the factors for them. All right. So if we only have two prime factors, like 2 and 3, and then it's determined by two factors. So here's the way how to count the factors. Okay, 12, a factor can be written in the form 2 to p and 3 to the q. Okay, this is a factor in the general form. Now, what are the possibilities for p? P could be 0, could be 1, could be 2, but it cannot be larger than 2, because otherwise 2 cubic cannot be a factor of 12. Okay, so because it's 2 square and 3 times 3, and the q even small, q could be 0, could be 1. Okay, so you have 3 choices for p and 2 choices for q, a factor. So yeah, a factor in the form p and 3q, and there's a 1-to-1 corresponds like that. You can have 2 numbers. Okay, so how do you count the number of factors? You have 3 choices for p, 2 choices for q. So total will be 3 times 2. This many choices. So why 3 times 2? You can look at the matrix type, right? P could be 0, 1, 2, 3, right? P could be 0. That's a variable p, right? Here's this side, p, 1, 2, 3, and 2. The q can be only have values 0 and 1. So you can have a 0, 0 and 1, and 0, and the 1 and the 1, right? And the 2 and 0, 2 and 1. You see? So you have this many combinations. Each pair of numbers corresponds to a factor. So this side you have 3 choices. This is a matrix, right? Kind of matrix, it's a square. This side is 3. It has 3 choices, and this side is 2 choices, and this side is 3 choices. Total will be 6. Okay, that's the reason you just need to do the multiplication. Okay, so 12 has 3 times 2, which is 6 factors. Okay. Okay. So we can also look at next problem. For example, some number which is going to be 7 cubed times let's say times 5 squared. Okay, this number is pretty large number if you multiply this out. Only to give you prime factorization. How many factors does this number have? You can list all of them, but it takes time, and also you will probably miss some. Like how many factors does this number have? Okay. Right, so the idea is that you write down the general form of the factor. Okay, a factor must be in the form, it contains factor 7, and there is also factor 5. But then the possible value for p is going to be 0, 1, 2, and 3. Cannot be larger than 3. Okay, and the possible value for q could be 0 and 1 and 2. Okay, so for example, like 7 square and 5 to the 1. So this is a factor. Okay, and you can actually divide. For example, 7 5 square, right? Divided by 7 square times 5, right? And then you can simplify. And when you simplify, you get a result, right? You can also write it like this. And it cancels some, okay? If you get 7 cubed, 2, actually 7 is left and 5 is left. So the quotient is 35. Yeah. So indeed, it's a factor, But the question is, yeah, every factor of this number corresponds to a pair of numbers, P and Q. Okay, how many choices for P? 4. How many choices for Q? 3. So that's why 7 cubed and 5 squared has how many? 4 times 3, which is 12 factors. It's hard to list all of them. Okay, it is not easy to list all of them. Okay. So I'm going to ask you to solve the following problem. How many factors does 48 have? Okay. Yeah, please try to do this. Yeah, first of all, you factor 48. You write 48 as product of several terms, prime numbers. Yeah. You have 10 factors.
I don't
You don't get.
get
You have 4 factors.
4 factors.
Okay, first of all, let's say 48. How can you factor? It's even number. It's divisible by 4 actually, right?
Yeah.
Right. So I think it's 2 times 4. Let's do like this quickly, right? And then 12 is 3 times 4, right?
Yeah.
So actually, how many 2's there? 2 to the 4th power times 3. Yeah. So times 3, right? 16 times 3 is going to be 48. So this is a fact. Okay. Then a factor must be in the form 2 to some power and 3 to certain power. But this P, the largest possible value for P is going to be 4. The largest possible for Q is 1. So there's only 5 choices for P, 2 choices for Q.
Okay.
Yeah, that's why. How many choices for the combination? You have 2 freedoms here, right? P and Q. Okay, so that's why they are, this how many of this P and Q, right? How many pairs of this PQ? And then, yeah, this is correspondence, right? You don't need to keep write 2 and 3 here, and just write on P and Q. So you have 5 times 2 this many factors. Okay, 48 has 5 times 2, 10 factors. Right? It's a little bit harder to list all of them, but if you want to list all of them, you have to list them like in the matrix form. Okay, you have a 5 rows, 2 columns. Okay, let's list all of them. Okay, so when P equals 0, 2 to the 0, and the Q is 0, right? 3 to 0. Okay, 2 to the 0, 3 to the 1. That's the first row. 2 to the 1, 3 to the 0, 2 to the 1, 3 to the 1. That's the second column. 2 square. This is how do we list all of them. Okay, 2 cube, 3 to the 0, 2 cube, 3 to the 1, and the last one, 2 to the 4, 3 to the 0, and 2 to the 4, 3 to the 1. So how many of them? You have a 5 here. You have a 2. So it's like an area of a rectangle. This side is 5, other side is 4. And how many of them, right? And the 10. So total, it's 10. Yeah, 5 times 2, that's 10 numbers there. Okay? Because each row contains 2 numbers, and there are 5 rows. So 5 times 2, 10 rows. Okay? A total 10 numbers. Okay? Got it? Yeah, I'm going to ask you to do another problem. And you're also trying to list all the numbers. Okay? This is how many factors does I don't want to give you the answer. Okay.
3.
Hmm?
97. Yeah.
I just asked you to do the 27. 28. Okay. Yeah. Please give me the answer.
Six factor. 6. Yes. Yeah, 6. Wait. No. Yes. Yeah, it's 6. Yes. Yeah. Michael said 6. So it's a microphone. That's why. Like everyone's saying 6.
Everybody's 6, right? 28 is going to be 4 times 7, 2 square and 7. So you will see that a factor must be in the form like that, right? And then P has 3 choices, Q have 2 choices. So that's why, 28 has 3 times 2, 6 factors. Okay, great. And another question we are going to be, okay, if a number has a factor of P, then we say the number is divisible by P, okay? Because if a number, can written in the form like that, right? Then in this case, P is a factor, Q is a factor, okay? P is a factor of N, okay, no question. We also said that N is divisible by P, okay? That's the way to talk about, right? And we can also say that N is a multiple of P, okay? A multiple of P means N is P times some another integer. So there are several ways to talk about this, okay? And we can say Q is quotient. We can also say P is also quotient when divided by Q. All right, so this is the thing. Now let's do the next problem, okay? My question is, I still do. This is going to be. Let's try 72. Okay, look at 72. How many? No.
Divisibility. Is it what?
Okay.
Yes.
How many even factors does 72 have? So we only consider the factors which are even number. Okay. So there's additional restriction on that. It's slightly different from the previous problem. Okay. First of all, you have to try to factor. Okay.
Do a factor.
Hmm?
You have to do a factor. No.
No.
Okay.
First of all, do the prime factorization. Right.
There's 6, 12, 2, or there's 12. 6 times.
Yeah, first of all, do prime factorization. 72 is going to be what?
12 times 6. 8 times 9.
8 times 9. You begin with 8 times 9. 8 times 9. 8 is 2 cubed, 3 square. So that's my hint, right? So then you says 9.
I got 5.
You got 5.
6 factors, 9 factors. 6 factors, 9.
Yeah. Somebody says 6 factors, but there's among them 9 factors. That's
I think it was 6. Oh, never got the 6. Oh, good. Yeah, I think it's 8. Yeah, 5. See, he's correct.
okay. Okay, let's do that. A factor must be in the form P to the power Q, 2 to the P and 3 to the Q. Okay. Now, in order to makes a factor to be even. P cannot be 0, so P, the choice for P is 1, 2, 3. The choice for the Q is 0, 1, and 2.
Why not 0?
If P is 0, then 2 is gone. So that factor is not going to be even.
Oh yeah.
Okay? So this is a factor in the general form. 2 to the some power and 3 to the power. But if 2 to the 0, then that's 1. No factor 2 there. So it's not even.
Oh, because 2 like.
Yeah, that's right. That's right.
Yeah.
So they are.
Well, if you remove the 0, that's like die 0.
Yeah. So you have a 3 choices for P and 3 choices for Q. Then they are 72 has 3 times 3, 9 even factors. Got it?
Yeah. Wait, what?
Yeah. So the next question is, so we want to find out all integers between 20 and 80, which are divisible by, let's say, divisible by 7. Okay, so that means a multiple of 7.
Oh,
Yeah, it's a multiple of 7, so divisible by 7 it's the same.
49.
Okay, question is how many of them there?
Okay, 4, 9. So 3, 4, 5, 6, 7, 8. No, list the last digit and then list every last digit.
Yeah.
Possible.
So think about a number divided by 7 must be in the form like 7 times 2. Okay, so this is between 80 and 20. So you just need to figure out what is the smallest possible value for Q. Okay, yeah. So if 20 divided by 7, right? 20 divided by 7 is going to be about 2 point something something. And then 80 divided by 7, right? It's going to be 11 times, right? So the possible value for the Q should be greater than, I think it should be greater than
It's 9.
3. So Q can be, the smallest possible value you can choose is 3, 4, all the way to 11. You cannot choose 12. 12 times 7 is larger than 80. So those are the possible, you figure out the possible value for Q to make the multiple of 7. Okay? You make a multiple of 7. So how many of them from? So there are 8 such numbers there. Yeah, you just say, what is the largest possible value for Q? Yeah, then you just 80 divided by 7, then to be, the Q should be less than equal to 11 point something. So Q cannot be larger than, wait a minute, should be 11, sorry.
Oh, yes. 9.
Yeah, that's right.
It goes
Okay.
to 11, right?
Yeah, that's right. Yeah, can be goes to 11, sorry for that. The other side, there must be larger than 2, which is 3, begin with 3. So you can list all the numbers, 7 times 3, 7 times 4, 7 times 5, all the way 7 times 11, which is 77. Okay, that begin with 21. So you can have all of them. Okay. Okay. Another one is okay. find all numbers, integers, okay? Integers, those are integers. When we say numbers here, usually means integers. Yeah. Integers, let's say between 100 and 150, and what that is divisible by, yeah, by 6 and 8.
What? 6 and 8?
Yeah.
Can you multiply? No, you can't multiply. What?
All right. Maybe you have such a number, maybe not. Okay, let's look at a number divided by 6 and 7. Okay, 6 is going to be 2 times 3, right?
Yeah.
8 is 2 times 4.
Oh, you need something.
Okay. So a number divided by a number divisible by is divisible by 6 and 8. You can combine to one statement if only if equivalent to say it is divisible by what? What number?
5.
No, it's divisible by 24.
Oh, wait,
Yeah,
Money?
divisible by 2 cubed times 3. Yeah, you learned from school already, right? So you just need a one number. Yeah, because 6. Yeah.
Benji, shut up. Don't you. Wait, it's Benjamin who's talking?
Yes.
Benji.
All right, 24. Now can you do the problem? So 24 times some q, right? Should be between 150 and you can find the smallest value for q and the smallest value for largest cost value for q. Okay, you use a division. So q cannot be smaller than 4, right? Q started from 5. What is the largest possible value?
Yeah, it's only 2. Yeah, it's 24 times. It's 1.
Yeah.
It's 24 times 5 and 24 times 6.
Yeah. So there are only 2 possible values. Then the answer is, yeah, the answer is 24 times 5, right? 24 times 5 is 120. Another one, yeah, it's 100. Another one is 24 times 6. Just add 24 there. 140. 140. 44.
Yes.
Okay. Okay, so sometimes they have a 2 solutions there. Now our next problem is, what is a list the whole number? Okay, divisible by.
Divisible by 5. 10. What is the list? Wait a minute. What does that say? Last? Least. What's that?
List.
Least.
Yeah, what is the list?
What? Oh, what?
Yeah, what is the list the whole number? Divisible by 14 and 21.
It's at least harder for everybody. Seven. I mean, 7. That's 7. 3. No, 7. No, 7. Let's do the good method.
7 is not divisible by 14.
Yeah, it is 2 times the big. No. Oh, I see. So it has to be larger than 42. It's 42. It has to be larger
Yeah.
than 14.
So 14 is 2 times 7. 21 is 3 times 7, right? A number divided by 2 times 7 divided by 3 times 7. So that number must contain 2, 3, and 7. Okay? So the list whole number must be 2 times 3 times 3 times 7. Okay? Yeah, that's going to be 42. Okay?
42.
Yeah, it contains.
Really dumb.
That's right.
All 4 and now you get the least 6 times 7.
Yeah, my next question is, what is
It's the LCM.
list? Yeah,
LCM. Yeah. It is the
you already learned that LCM, right?
Yeah, we're learning it in school right now.
Oh, in the grade.
It's so dumb though. Why would you use?
Okay,
Why do you want that?
so divisible by 2, 3, 4, 5, 6, and 7. Let's say and 8. Okay.
Why is the least? Who made that face? That Benji again? Yeah, that one's easy to make.
All right, so you're looking for the list of whole number divided by all of them, all this number.
70.
That number should be divided by 2, should be divided by 3, divided by 4, divided by 5, 6, 7, and 8.
Never mind.
Because this is possible.
You have to see which what was 7's prime. Well, then you have to include it. Yeah. So you see that times 7.
Don't talk, okay?
210. How do you 210?
Don't talk, okay? Don't discuss. You focus on the problem first.
Okay.
You figure it out, then let me know. Okay?
210.
210.
Yeah. 210. I got 260.
You got 260.
Wait, I'm trying to figure it.
Yeah, I'm going to ask you.
Wait, what is it?
Just be quiet. If you already answer the question, be quiet. Okay, I'm going to. Okay.
Is it 200?
You have to collect all the factors from those numbers, okay? Yes.
Is it 210?
Okay, be quiet. Maybe right, maybe wrong. Okay. So Michael got
Yes, 210. See, I told you.
40 or 400, 40,000.
40,380.
20.
Oh,
All right, let's look at all the possible, all the factors, okay? 4 is 2 square, 6 is 2 times 3, 8 is 2 cubed. So a number divisible by any of those numbers, at least divisible by 2 cubed, right? This is the highest, right? If it contains 2 cubed, then it don't worry about those 2's here. Then you also should be divided by 3, right? Then should be divided by 5. Then divided by 7. That's it. If it contains all those factors, you're fine. Okay? So the answer will be, right? So it's going to be what? Are you sure it's 210?
No, 210 is 2 times 2 times 5 times 7. But you need 2 square? Yeah, I don't know what you need.
You need a 2 cubed.
What do you mean 2 cube? Yeah, but can't you just use okay, just use 2?
I cannot use a 1, 2. If it's used a 1, 2, then it's not divisible by 8.
Oh yeah, right.
Okay?
Oh, because there's 3 numbers that.
Yeah, it should be divisible, not just collect all those prime factors. Yeah. So 8 times 3 times 5 times 7, it's going to be 840. See, nobody can hear us, right? All right. Why? So, it must divisible by 8, so it must contain 8. Clear? Yeah, it's also divisible by 3, so it contains 3. It contains 5 and 7. Just list all the factors here. Okay, nobody got it.
Isn't this more like GCF?
Yeah, this is smallest integer.
It's like no, because it has to be larger than what's GCF or GCM. No, it's still LCA.
All right, so we're talking about divisibility. Next step, we are going to study remainder quotient. Okay, let's begin with this number, right? Everybody knows how to do 14 divided by, let's say, divided by 6. So this is, you know that, right? So what is this? Okay, this is not, yeah. Let me use the 13, okay? So I get a 1. So 2 is a quotient, and this is called the remainder. Okay? So, yeah. So that means 13 equals 6 times quotient plus the remainder. That's one identity. Okay? And if both sides divide by 6, then 13 divided by 6 is even 2. There's the remainder divided by 6. That's another way to describe it. Okay? So if you have a number divided by p, right? Then you're supposed to get a quotient. And then I is called the remainder. Yeah. How do you describe the relationship among them? N divided by p, get a quotient. Then the remainder is still there, so you divide by p. Okay? You can also multiply both sides by p. So n is going to be pq plus r. Okay? Now the interesting is if we subtract the remainder from the original number, that's going to be p and q. This should be divisible by p. Okay. So this is a general theory, and we begin deal with the numbers. Okay. All right. So let's take a look at the next problem. Okay. We
另外弄个像猕猴桃吗？
okay. Let's see. So we have the following: a number, a positive. Okay, a positive, a number, n divided by 5 leaves a remainder of 4. No, you cannot have 4. Remainder must be less than 5. Okay. My question is, I don't know the name there. What is the remainder when it's when 2n divided by 5?
The age is 14. Positive number divided by 5. What is the remainder? What is the remainder? 1 is 2n divided by.
Okay, first of all, we don't know the value of n. Okay, so you can all, of course, to answer the question, the answer could be cannot be determined. That's a possibility. So it can be determined, right? So maybe the answer can be determined. That's unique answer here. So if you have new ideas, what you do is you choose a special value for n. Then you do the computation. For example, n divided by 5 has a remainder 4. N could be 4 even.
What? Bring up.
Right?
N could be 14.
N could be 4. Because when 4 divided by 5, the quotient is 0, the remainder is 4. So that's just, so let's try some examples, okay? Let's try some examples. So this is a could be 4, right? Another possible answer is going to be 9, right? So let's say 2n is going to be 8. If 8 divided by 5, right, divided by 5, what is the remainder? 3. So let's try this. 2, 9, 18, right? 18 divided by 5. 18 divided by 5, remainder is 4.
No, 3.
Still 3. Now, right? And then they try, what is next one? 14. Yeah, 14 divided by 5, the remainder is 4. So 2n is going to be 28. 28 divided by 5, the remainder is also 3.
What?
So now, here's the difference between mathematics and biology. For example, biologists will conclude based on my 3 experiments, my jump conclusion is always equal 3. That's it, and publish a paper. Okay. Mathematician says you just 3 examples. How do you know when n equals much larger number? You never give proof, right? So that means this cannot be called the truth.
So the
So,
answer is
no,
zero.
no, no. So you have, you know, for this particular problem, your answer maybe say, you can say answer is 3. They put 3 there. The answer maybe is right, but just look at 3 examples here, right? So how do you solve this problem in give a definite answer? Is if n divided by 5 leaves the remainder 4. So that means 5 times q plus 4. Got it? Yeah. So
Oh yeah.
yeah, that's right. Because divided by 5 leaves the remainder 4. So let's look at 2n. 2n is 2 times 5q plus 4, which is 10q plus 8, right? But 8, if you divide by 5, has a remainder of 3. So what I'm going to do is I'm going to write a 5 plus 3. Okay? So this part can be combined into in the form like, for example, take a 5 out, 2q plus 1. So 2n is written as 5 times something plus 3. So this will be the remainder, always the remainder. We give the proof. Okay, this is always a remainder. Remainder is always 3. So quotient, even you can get a formula for the new quotient. It's going to be 2q plus 1. If the original quotient is q, then the new quotient will be 2q plus 1. So this is a true, yeah, this is a true in general. Okay, so we prove this, right? So let's do the same problem, similar problem. Okay, yeah, a number, an integer. Okay, an integer. Sorry, it's not number. Integer. Let's use integer. A positive integer n divided by 7 leaves a remainder of 1. Okay. Now, what is the remainder if 3n divided by 7? If 3n is divided by 7. Okay, and you can use examples to conclude that, or you can, because in general this is a definite answer, so right? But I suggest you to work out in general. Come on.
Wait, this microphone right there. It's Shen's phone. Yeah. But that's Shen. That is him. Yeah. It's Shen. No. What he's doing, what the person is doing, he's making sound that he's muting himself. And then we don't know who it is. We're gonna repeat that.
All right, so let's do this.
You out. Bad people. Don't do that. You want to get your
Be quiet. So, how do you figure out this one? You can choose a special number n.
Is it 2? Is it 3?
I think 3 is the answer. You can let n to be 1. Then 3n is just 3. 3 divided by 7, right? So n equals 1, 3n equals 3. When it's divided by 7, the remainder is going to be 3. That. Right? And in general, why is this true is n is going to be 3. N divided by 7, it's 7 cubed plus 1, right? Then you multiply by 3, and then there'll be 3 times 7 times cube plus 3. So 3 is still smaller than 7. So this definitely is a remainder. Okay, and this part can be written as 7 times 3 cubed plus 3. Okay, so that's that. Yeah. All right, so now we are looking at some more challenging problems. All right, here's the question. What is the least positive integer? Right, and this integer should be greater than 3. That leaves a remainder of 3 when divided by the following numbers.
Yes.
When divided by 4 and 5.
What?
Okay.
Someone get.
So we are, of course, there are plenty of numbers there. Leaves a remainder of 3 when divided by 4 and 5. Now, if I remove the restriction greater than 3, 3 is the answer. Okay, because when 3 divided by 4 divided by 5, you get some remainder, 3. Yeah. So now, right, it's lots of people get answers. Do you know how to get? Okay. So the number, okay, divisible, if you divide by, leaves a remainder of 3 when it's divided by 4. That means if subtract 3 from the number, this should be divisible by 4 and 5. Do you agree? Yeah, because this should be divisible by, because this is the way how to write. So if you get rid of the remainder, then that number is going to be divisible by 4. So a number divided by 4 and 5, what is smallest possible value? 20. That's right. So n is going to be 23. That's the smallest possible value. This is how do we get it. Okay? Yeah. Now I'm going to change the problem a little bit. Yeah. So here's another question. What is the least positive integer, okay, which should be greater than 4, that leaves the same remainder of 4 when divided by the following numbers. Okay, when divided by 6 and 8. Okay. Yeah, 6 and 8. How do you do that? Well, divide by 6 and 8 to give you the same remainder, right? So that number divided by 4 should be divisible by 6 and 8. But yeah, the smallest number which is divisible by 6 and 8, what is that number? 6 contains fact 2 and 3, right? Yes. Yeah, 2 and 4, 2 cubed. Okay. So combine them. It should be divided by 24, right?
Yeah.
This part is 24. So the smallest number which is divisible, positive number divided by 24 is going to be 24. Okay, so it's 24. Yeah, 24 plus 4 is going to be 28. 28. Okay, that's cool. All right, so the very last, I'm going to talk about how do we add the number together, like 2 to the 0, 2 to the 1, 2 square, 2 cubed, 2 to the 4th. How do we add them number quickly?
I just spent too long with the time memorizing all that too much.
Okay, so the idea, so here's the idea. The idea is you let them to be the sum, right? What I'm going to do is I multiply each term by 2. So I get 2 to the 1, 2 square, 2 cube, 2 to the 4th power, 2 to the 5th. Okay? Yeah.
Could you just add all the numbers together, then add all the exponents together, and then use the exponents on?
No, you cannot. There's no such way you can do it. You cannot. No. But who tell you you can do that? So you see that this part the same, right? So now I'm going to subtraction equation 1, equation 2. Equation 2 minus equation 1. Then you get only one s here. Then what? The common part cancels out. You get 2 to the 5th minus 2 to the 0.
What's 2 to 0?
0? 2 to the 0 is going to be 1.
Huh? What? Wait, anything to the power of 0 is 1.
Yeah. So actually you can, it's interesting, you can add it all together, just only get 2 terms. Okay? Why this works?
How does this work?
It's a weird, right?
Wait, what does the 2 minus 1 represent? Oh, equation 2 minus equation 1. Oh.
Yeah, equation 2 minus 0.
Yeah. Like what are you doing 2? Oh, because then you subtract the 1, 2.
Yeah, so this common part is canceled out. So in other words, in general, if we have 1 plus 2 square, 2 cube, all the way to 2019, right? Okay. You can get 2 to 2020 minus 1. Can combine into just only 2 terms.
Wait.
So 2 to the 2020 is pretty large number.
Yeah.
It's almost equal to the sum of all those numbers. Okay. So you get this in the same idea, using the same idea. Okay. Yes.
Why did you add an extra 2 to the power of 5 and reduce 2 to the power of 0?
2 to the power 0
Like,
is
why did you just do 2 to the power of 0 on the first one so it can be all canceled out?
I cannot 2 to the power 0. I don't know. It's kind of, I don't understand question. Okay. First of all, when you cancel something, you have to use you have to follow the algebraic rules. You know, they cannot do whatever you want. You know, like what he said, they add all the powers together. No, you cannot add them together. It's not a multiplication. Okay. You know, 2 cubed times 2 to the 4th, you can say 2 to the 3 plus 4, 2 to the 7th. Okay. But 2 cubed plus 2 to the 4th, you cannot add the powers. Okay. All you can do is you can take 2 cubed out, and which is given to 2 cubed, and the 1 plus 2, and this is actually is going to be 2 cubed times 3.
Oh, so you can just add all the powers together?
Yeah, it's multiplication, you can do that. But it's addition, you cannot. So you can take the common factor out. Yeah. Okay. And similarly, let's do the problem. Similarly, it's going to be 3 to the power 3, 1, 3 to the square, 3 cube, 3 to the 4th power. Let's do this. Let's try to simplify to only 2 terms maximum, right? Now, how to do that? We don't want the multiply.
Yeah, 3 to the 6 minus 1. So minus 1.
No. But how do you know that?
Oh, it equals like
All right. So you let S to be 1, Q, right? We repeated the same. Okay, how do I do that? And I have to multiply by 3 instead of 2.
Wait, what?
Because I need a 3 times 1 is 3. 3 square, 3 cube, 3 to the 4th power, 3 to the 5th, 3 to the 6th. Yeah. Yeah, I multiplied, not add. Okay, I multiply each term by 3. Then I find out this is a common part. I do the subtraction again. But this side now it's not just 1s, it's 2s. Then I get 3 to the 6 minus 1 on the top.
2s.
Then 3 to the 6 minus 1 and 2 over 2. So it's not just you know, you have to divide by 2. Okay. In general, you have the following formula: 1 plus r squared rq to r to the nth power is going to be r to the n plus 1 minus 1 divided by r minus 1. Okay. All right. Right. Yeah. So this is a formula one can use, and if I have a yeah, let's do the following problem, then finish. Okay. Find the sum of all factors of the following number, and that is going to be 24. Okay. Now, first of all, how many factors does it have? 24 is going to be 3 times 8, 3 times 2 cubed, right? So it has 2 times 4, 8 factors. All right. The problem is how do you add them together? Okay. So let's list all the factors here. 3, 0, and yeah, let's try this other way.
There's 8 factors?
Uh,
I got it. It's 1, 2, 3, 4, 6, 8, 12, 24. So basically how would that be? There's basically a really large number. How would you do this? Exactly. So you can't just start fancy.
right? So in total you have 8, right? You want it all together, right? You want all the air together. How do you add them together? I think we should try this. Add all those column together, okay? So you will get, you have a common factor here. It's 2 to the 0, 2 to the 1, 2 square, 2 cubed, and plus okay? And you will also see that this is the same factor before even find out, right? So it's actually the product of those numbers, right? So the question is, maybe you can figure it out you without using formula because the power is small. So I can say 1 plus 2 plus 4 plus 8. Here's 1 plus 3. So what is the number? 15, right? Yeah. What is the number? 4. So it's 15 times, yeah, 6. Okay, so that's how do we get it. Okay, yeah, let's stop here and you will get an assignment. Wait.